All right, guys, today what I want to cover is how to read the Airoverse control design documents. And to do that, I also want to cover a couple quick things on mechanical, electrical, plumbing plans as would be done by engineers. I picked a sample project we're going to go through. Um, Believe me, guys, I know when you're rolling around in trucks and all that stuff every day doing service, install, when you open up a set of plans like this, when you're not comfortable with them, it's a lot to take in the first time. My goal today is to break it down and simplify it for you so that you can actually make use of it and you can make use relatively quickly going forward and learn that these things really aren't as daunting if you know what you're looking for. There's just a few things you need to know what you're looking for, and then you can really kind of hone in on your time. So with that, I'm just going to jump right into it. What we're going to start with here, step one is going to be what equipment is on the site and physically where is it, how do I find it? So to know step one, first you got to go through the MEP plans. These would be done by the engineer before we even did a design usually. These are the paper prints that you might find in a closet somewhere. And the first thing I do when I open up these plans is I go to the mechanical section. It's going to be the M section, usually about 3/4 of the way down a combined set. And what I want to find is the HVAC schedules or the plumbing schedules. And if I zoom in here, all those is a list of all of the equipment, all the physical equipment that's on the site. So this site's going to have 3 exhaust fans. It's got one single air handler with a mark AHU1. There you go. You can see AHU1. It's a York XTI 102X with these characteristics. These notes are associated. None of that really matters. What I'm trying to do is figure out how much equipment. There's only one condensing unit. And here we go. This is what we're going to spend most of our time on is the VAVs. Looks like there's 1 through 26 VAVs on this project with varying characteristics. No notes on those individually, a couple mini splits. You get the idea. It's just a big list of equipment. And let's go ahead and find one of these. So now we know what equipment is there. We can see in a list how many pieces of equipment I'm expecting to find. And using this mark here, I can take V1-01, for example, our first VAV. And then we're going to go to our HVAC layout. We're going to scroll up. We're looking for ductwork. That looks like plumbing in the red there. Okay, here we go. My HVAC plan here. Now we're going to zoom in on my HVAC plan, which on this job is 2 pages. And all right, so I'm looking at ductwork. This engineer did a really nice thing and they color coded the ductwork. So let's zoom in and see which one's supply and which keeps dropping at the bottom of the page. All right, so this looks like my air handler. It's back in the mechanical room, obviously. The ductwork's the biggest back here. And what I'm looking for is this X. If there were no color coding, the X always shows me what is my supply. The slash, the single slash, shows me what is the return side. Okay, so we're going to trace out our supply side, and we're going to look for the VAV icons, and we're going to look for the label. So actually, the very first VAV I found in the ductwork is V1-01, which serves this area in the library. V1-04 goes up and serves the children's area. But really what's important is being able to find the VAV box itself. And the sensor, is going to be somewhere in this area. And the VAV is going to be right in this corner of the wall above the ceiling. So if you're going to start dropping your ladder, don't just drop it anywhere. Go right here, drop it under there, pop up, and you're at V1-01. All right, that's all I really want to cover on the MEPs. Now you know what equipment is on the job. You roughly know how to find the equipment using the mark or the label of the equipment. So now you're a little bit more efficient about tracing that ductwork, getting out to the device you want to get to without just randomly dropping your ladder, popping tiles, stuff like that. All right, so step 2, we're going to switch from the MEP. Now we have the marks for each of the pieces of equipment, and we're going over here to our controls design drawing. And our controls design drawing, what we're really doing first, or our step 2 in this whole process, is going to be what equipment is correlated to what controls devices. So as we go through, there's kind of a recap here, but this is devices instead of equipment. So usually there's a controller for each piece of equipment or each piece of equipment that's connected. So I've got 26 of the smart nodes. Those have a label on it. These are a device label, just like you had an equipment label before. Same thing for a handful of hyperstats. Those are talking back to a CCU over the mesh, as you can see down here in the key. And then that's talking to a custom control panel via a wired connection, which is talking to a bunch of backnet devices on a trunk here, back to that panel. So if you need to trace any of that wiring, you got it. And then this is really, really important for tracing all of your equipment from the MEP drawings that we had just looked at in our step 1 to the devices. So now we've got a tag. These are our device tags. So if I take SN1000, SN1000, it's my smart node 1000, it's just a label. That is corresponding to V1-02 from my MEP plans. So now this controller is controlling this piece of equipment. Zone is really the equipment. The tag is your device. Okay, so we were looking at V1-01. Scroll down, that's in the list here. That's actually SN1024, V1-01. And then I can see my profile type. That's going to be the application specific profile it's running. So what sequence of operations is it going to be using? What selection do I make? That's right here, VAV reheat no fan. That's the selection, that's the type of application it's running. And then the drawing is VAV hot water with multi-sensor, or VAV HW with MS. And you see all 26 of those VAVs are here, and those are corresponding with the same drawing. So if the control points are identical amongst them, even if their characteristics are different, you don't need individual drawings for each VAV. You've got one drawing that represents all 26 VAVs. Same thing for your unit heaters. There's a unit heater drawing, and then there's a big AHU plant wiring drawing for CP1. That's that custom panel, and AHU1. Okay. All right, so let's go ahead and look at VAV1. We're just using it as an example to show how to go through these drawings. So you did step 2, what equipment is correlated. This device schedule shows you how to correlate the equipment with control devices. And the third and final step is going to be how are the controls wired to these pieces of equipment, which is shown on our drawings here. So we scroll down, we're going to a VAV. So you see VAV hot water with multi-sensor with MS. So down here, maybe I need to zoom in a little so you can see that closer. Oops, too far. There you go. So you see under drawing, oh my gosh, that thing keeps getting in the way. Drawing, VAV, HW with multi-sensor, that's how you're tracing from that device schedule out to the actual drawing. And each of these drawings is broken into 4 quadrants: logical, point list, physical diagram, and our sequence of operations. More complex pieces of equipment, the quadrants might be on multiple pages. You might have 4 pages to cover each quadrant on more complex equipment. But we do include all 4 because they're all very important to getting it wired and configured properly. So let's zoom in and we'll go through these one by one. So our logical diagram here, this is showing you a logical representation of the piece of equipment. So in this case, it's a VAV. So you have supplier coming in, running through a damper VAV box, running over a hot water coil, and then discharging air into the space. All the blue text is associated with sensors and control points. So each blue text is a point that will be coming from or going to the controller. So if we take like our damper control signal, for example, this is coming from the controller going into the damper, controlling what position to set that to. And I know that it's a signal coming out of the controller because of the arrow direction here within this shape. So the arrows are pointing into the VAV. So that's telling me that it's a control point coming from the controller and going to the VAV damper actuator. The shape of this also matters. They're all circles here. That means that these are proportional points or modulating points, basically points with values between a minimum and maximum that have a range that can be anything in between. If this were a square or rectangle, that would tell you that it's a binary point and that it's simply an on-off point. Okay, got my discharge air temperature here, those things. So let's go ahead and figure out what point my damper control signal is coming from. So I go over to my points list and I'm looking for damper control signal. Damper control signal right here is coming out of AO1 on my controller with the tag DMPR, damper. There's some other information over there that's you probably won't have to use. But AO1 is where my damper control signal should be landed. And if I follow the DMPR tag around the document, I can trace those wires. Okay, so let's go ahead and find the DMPR on my physical drawing down here. Okay, DMPR is my damper. It's got 4 wires. It's got a green, white, black, and red. And if I zoom in a little further, I can show you where those go. So my white wire is coming from AO1, that's the actual signal. It's going to have a ground, G&D, it needs 24 volts and ground to power the damper. And then the green wire is actually coming back to be my universal input 1. So a feedback signal. All right, and next to damper, I have this diamond shape with a 9 in it. That's note 9. My RHT, my reheats. If I go up to my points list, my reheats, my command is note 10. So those notes we're going to get to here in a minute. I want to cover our final quadrant first. The final quadrant is a sequence of operations. This is a field level understanding of the piece of equipment and the sequences that are going to be used. It is not a comprehensive view of the sequences by any means. It's not showing you calculations, it's showing you when to expect cooling, heating, fan, or whatever else is relevant to that piece of equipment. What is relevant to you are the commissioning notes. So as you're actually setting up pairing the software side of this, this tells you some specific selections to make as you're setting it up to make it operate with the type of equipment that you were sent or have on the project. All right, so now back to wiring. Let's follow these notes around. So let's find notes 9 and 10, and maybe we'll find 6 too for my supply air and discharge air temps. Zoom out. So those notes actually are on the last few pages of the drawing. On the last few pages of the drawing, I have these notes. You see diamond shapes 1, 3, 4, 5, 9, and 10 here, and 6. So they're all here. Let's go ahead and zoom in. This is what's on the other end of that wire label. So as long as we had the information about the equipment or the actuators, sensors, whatever was sent, we can trace that note 10, that valve, those wires, 3 wires here, black, red, white, shows you specifically where to land them on the actuator you should have. Same thing for note 9, my not modulating damper actuator has 4 wires, it's got that green wire for feedback. And my note 6 is showing me my airflow temp sensor. Wires are non-polarity or non-position sensitive. So where those 2 wires go on the other end are not polarity sensitive. Zoom out. You can see that there's some more detailed ones for things like static pressure sensors, those network adapters, and then for specific devices. So this is with a Techmar slab control, the boiler controller, what have you. If we have the info, it's telling you specifically where to land the wires. So that's pretty much it, you guys. That gets you through all three steps. You know, step one was going through the mechanical, electrical plans to be able to figure out what equipment is on the site, where to find it. Step two, what equipment was correlated to what controls device. That was up in the device schedule on our plans here. So don't ever forget to use this device schedule. And step three was how are the controls wired to the equipment. We gave you an example with the VAV for how to wire it and how to trace the nodes to the end so you can see specifically where to land your wires on the controller uh, and the equipment or devices, sensors, actuators, stuff like that. The same thing is true for bigger stuff. When we design custom panels, you get just a much larger points list, get a much larger physical wiring diagram that shows you where on the panel to land each one of those wires. And then those go to the end of the document if we have the info on the sensors that are going to be installed. Um, but it shows you all that. So that's pretty much it, you guys. I really hope this was useful. I hope this simplified, kind of what you're looking for in these drawings. Made it a little bit less scary to open up one of these and kind of trace through and have all the information you need to find the equipment and wire it up.